All right, STAT1800. The purpose of this video is to get into organizing, visualizing categorical and quantitative variables. I'll tell you, I'll be very completely transparent here. It's not one of my favorite videos, but it's just stuff that we need to cover and I need to present to you so you can be prepared to succeed in the class, right? All right, STAT1800. The purpose of this video is to dive into organizing, visualizing categorical and quantitative variables. So let's go for it. So what I'm going to teach you are just ways again to once we collect categorical variables and numerical variables, how can we visualize and organize those? Some of this is going to be very straightforward stuff that you've probably seen before, and I think there will be a couple things that maybe you haven't seen before. So specific to categorical data, it really depends on whether we have one categorical variable. Let's say that we're looking at maybe just political affiliation, in which case we would have, again, one categorical variable where we would use a summary table. If we have two categorical variables, maybe we're looking at the relationship between political affiliation and I don't know, beliefs, pro-life versus pro-choice. Then we would use what's called a contingency table. So I'm going to give you some examples of those, how we organize and how we summarize. So the summary table is really easy. So the illustration we have here is what if we were interested in examining the different devices that millennials use to watch movies or TV shows. So took a random sample of 278 millennials. 136 of those reported that they watch television set. That seems so archaic to say television set. Okay, well, whatever. 25 tablet, 28 smartphone, and 89 watch on the laptop or desktop. And the only thing that we do here is we create a frequency table, or I'm sorry, a frequency column, and then the percent column, which is just 136 divided by 278. Which gives me the 48.92 rounded, however my stat lab would instruct you to round. You'll notice that when we add these percents, it doesn't add up to be 100%. It's 99.99. That's just simply due to rounding. Contingency table helps us transition into organizing two or more categorical variables. And an example of a contingency table, let's say that we're examining invoices across either small, medium, or large. And then we're comparing the number of errors, which has been categorized as no errors or an error was committed across these different sizes of invoices. So you can see that the chart's very straightforward. This 170 represents the invoices that were small and contained no error, and the 20 represents the invoices that were small that contained an error. So there were 190 total small invoices. The 65, on the other hand, would represent what? It would represent the total of the number of errors that were observed. So the total sample size will be this number, which is equal to 400. Now, it gets a little complicated when we start summarizing these. So let me show you a couple of ways, actually three ways, that we actually categorize or summarize a two-way table. Now, the first way is to look at the percentage of overall total. So in this case, we would take the 170 and we would divide by 400, which gives us 42.5%. We would take the 335 and divide by 400. We would take the 140 and divide by 400. We would divide every one of these, all 12 of these, by the overall total to get the percentages that are put here. Now, another way of summarizing a contingency table is based on row totals alone. Now, let's say that our emphasis here, let's say for some reason in the report that we were creating, we wanted an emphasis on the either small, medium, or large amount, but we wanted the errors included, but we wanted the focus on the rows, which is again small, medium, or large. So what happens here is the 170 is divided by 190. All the focus is on the row. The 71.3 is 100 divided by 140. The 28.57 is 40 divided by 140. All of the divisions are made according to the row total, not the overall value. So the 335 is divided by 400 to give 83.75. The 65 that I'm circling is divided by the row total, 400, to give 16.25. This 100 right here, what's it divided by? It's divided by the row total, 140, to give 71.43%. Now, compare that to the column total. What does the column total do? Well, as you would expect, it divides by the columns, the total of the columns. So our focus on this first column is 335. So we take 170 divided by 335 to get the 50.75. We take 100 divided by 335 to get to 29.85. We take the 70 right here divided by what? The row total. I'm sorry, the column total, 400. So this 17.5 is found by taking 70 divided by the column total. So what we have when we do the column total, row total, overall totals, what we divide by is focused on either the overall value, the column total, or the row total, depending on the way that we are instructed to create the table. So in this case, where we're examining the column total, that would tell me that we have more emphasis on the percentage of errors than we do necessarily the small, medium, and large amount of the invoices. So that can be a little bit complicated, but again, you just have to wrap your mind around what percentage, again, overall, row, column, are we focusing on. Now, numerical data, we get into frequency distributions and cumulative distributions, and I'll explain all that through an example. So a frequency distribution is just a summary table where our data are arranged in ordered classes. So I think instead of me reading this all to you, I think it's going to be better demonstrated through an example. So let's say that a manufacturer of insulation randomly selects 20 winter days and records the highest daily temperature in degrees Fahrenheit. So we have 20 numbers there, 24, 35, ranging, well, not ranging, but going all the way to 27. What we want to do is we want to organize that data and put it in a frequency distribution. So the first thing we would want to do is sort the data into ascending order. Again, this is just for an illustration to show you how these things are created. From now on, once we actually observe a frequency distribution and how it evolves into what we call a histogram, from here on, once we, if we need a histogram or a frequency distribution, we're going to use StatCrunch and create that. But liberally educated people should know where these things come from. So again, backtracking, we sort the data from small to large. The next thing we do is we find the range, which in this case would be the highest number, 58, minus the smallest number of 12, which is 46. Next thing we do is select the number of cases, classes. This textbook uses 5. I would actually use 7. So what I would do is I would take 46, which is the range, divided by 7, and I would get 6.5. Well, I would probably round that up to 7. So 7 would be my class interval. They chose 5. 46 divided by 5 is 9 point something. They rounded up to 10. So 10 makes a cleaner class boundary. So what they did is they started at a number below the lowest. So the lowest number is 12. So they started at a nice clean number below 12. So they went from 10 to 20 because the class interval is 10. Went from 20 to 35, 30 to 40. Again, all of these are defined by the class interval. Now, the way I would have done it would have been 7. So it would have ranged from what? 10, but less than 17. 17, but less than 24. And you can see it's just not as clean because we just kind of get comfortable with 10s and 20s and 30s and 40s. Next thing, compute the class midpoint. That's pretty easy. Just find the center of these two values, 10 and 20. The easiest way to do that is just to average them. And then we do count observations assigned to each class. So what happens? We go through and count. So from 10 up to, but not including 20, you'll see that we have 3 observations. So we put a 3 right there. From 20 up to, but not including 30, we have 1, 2, 3, 4, 5, 6. And so 6 is the frequency. The next thing we would want to do is add relative frequency. Relative frequency works just like it did with the categorical variable before. We have 20 total numbers. 3 of those are from 10 to 20, not including 20. So if we take 3 divided by 20, we get 0.15. 6 divided by 20, we get 0.30. And then we report those as percentages. Something else we may want to add are cumulative percentages, cumulative frequencies. A cumulative frequency just means we add them up as we go. So we have 3 in this class. We have 6 more in the next class. So we have a cumulative frequency of 9. We have 5 more, which increases the cumulative frequency to 14. So our cumulative frequency, as we add these up, when we get to the end, it will be equal to our total frequency. To find the cumulative percentage, just take the cumulative frequency divided by the total. So 3 divided by 20. Take the cumulative frequency, 9 divided by 20, 14 divided by 20, 18 divided by 20, and so on and so forth. Now, categorical data, I want to keep this simple. I'm giving you different ways to visualize data. If we have one categorical variable, if we have 2, we get into side-by-side bar charts and donut charts and Pareto charts. I want to keep it simple and just look at bar charts and pie charts, because those are the ones, and a Pareto chart, because those are the ones that we encounter most of all. So a bar chart, not to be confused with a histogram. Histograms go with quantitative variables. Bar charts go with categorical variables. The bars, okay, again, tattoo this one to the brain, get this one in your notes with flashing neon lights around it. A bar chart, the bars do not touch. So a bar chart works for categorical variables. The bars do not touch. There's a space, there's a gap. Histograms go with quantitative variables. The bars, as we'll see in just a couple of screens, they do touch. So it's really easy. The television set, these are rounded from the previous example. We go to 49%, which just tells me we're going to bring this bar out to where it is at 49%. Pie charts, just partition out a circle, a pie, proportionately. So since television sets were 49%, they're about, we've rounded this stuff, we would have a slice of the pie that is slightly less than half. Laptop, desktop is about 32%. So that tells me that about a third of the pie should be represented by laptop, desktop. And again, we don't have to, we're not back in the Stone Ages. We don't have to create pie charts by hand. We have technology that can create the pie charts for us. But the main thing I want you to know at this point, at least, is that a pie chart is for displaying categorical variable. Now, a Pareto chart, interesting. Let me let me kind of motivate it. Okay. So first of all, we have causes of incomplete ATM transactions. And some of the causes they give are a warped card jammed, an unreadable card, and sometimes at the very bottom, lack of funds in the account. Now for this sample of 724 incomplete ATM transactions, 365 were a warped card jammed. That's 50.41%. The card being unreadable, 234, and that's 32.32%. Again, this 32.32% would be found by just taking 234 divided by the total, 724. Now, if we want to transition that into a Pareto chart, this is the way we do it. It's just a cumulative value starting from the most common, in this case, incomplete reason for an incomplete ATM transaction. So that's one of those things you have to, again, tattoo to the brain. For a Pareto chart, we're visualizing categorical data, and to make this thing appropriately, you have to start with the category that's the highest, the second highest, the third highest, the fourth highest, and so on and so forth. So if I go back, you can see that I have these frequencies from highest to lowest. So this would map directly onto the sequence of presenting the different reasons for incomplete ATM transactions. So again, it's cumulative. This is about 50.4. But if I add 50.4 and 32.3, I get about 83. So that's the reason this point right there, if I bring it over, you can see that that's about at 83%. So it's kind of a cumulative frequency measurement, as we've seen before. Numerical data. I want to get into histograms here. So let's see how those work. So a histogram again. What should you know at this point? You should know that a histogram, there are no gaps that the bars touch. And a histogram is a picture of a frequency distribution. And you should know the histograms go with or visualize numerical quantitative data. So this is the way a histogram works. Remember when we broke down from 10 less than 20, we had a frequency of 3. So notice that from 10 to 20, we have a bar that goes up to 3. Notice that from the 20 to less than 30, there's a frequency of 6. So it should be no surprise that the height of this bar is equal to 6. And we get a histogram. So again, pretty simple stuff. Now again, we're not gonna, if we need a histogram in this class, which we will, we'll have assignments where I'll ask you to create a histogram using data. We won't do these by hand. We'll actually let StatCrunch create those for us. All right, gang, that's all I got. Take care.